material. Your hair there, but your hand, you're the, so tell me what a ferromagnetic material is. It's the ability to become, it's the steel on the front of your fridge. Okay, it's a piece of iron. It's supposed to. It's not magnetized necessarily right now, but it becomes. Definition for a domain a little bit easier because I've kind of just given you a hint. It said that the definition of domain is ferromagnetic. Yeah, okay. It's inside a ferromagnetic material presented by less not a lot, not a ferromagnetic. Think of your desk right now before you do anything to it to magnetize it. Magnetize that we inside material may influence them. This become a magnet, a temporary magnet that will have its effect disappear, magnetizing object disappear, taken away. That's a temporary magnet. The other way really magnetizes. Should just apply an electric current from one end. What we can do is wire, put that generates a magnetic field, and the magnetic field will influence the domains inside this ferromagnetic material just in the same direction. Determine the polarity of new electromagnet would become. I want to spend some more time. The magnetic field that's generated, it's the electromagnet that's produced, but just wire. And it's down for time, a few hours. First, sit down at your desk with a compass and you try starting again to go to now. For itself. was. Logical conclusion. But that, oh, is the light causing a magnetic effect? Cause a magnetic effect. Light. Yeah. Well, that wire coming from the treasure map on top of the wire, and the compass. The compass in a direction. In the Earth's magnetic field, how do we know that? It's not just can be weak, and it's 5 Tesla. Yesterday was the Earth's magnetic field. Good. It was a weaker point cell. From the Earth one, send it this way. Let's see. And the most important because just about every bit of technology your iPhone, your stove at home, to the projector. This technology, moving charge through a wire, electric currents, right? Think of this. The ions through the air, alpha particles moving. Generate magnetic, but it's something that nobody else had discovered prior to 200 years. You got a compass. Flip off the current. Flip on. Let's move the compass down. Well, all that very useful of the electric going in whatever direction. It's a very shape. It's produced by these every single time notation that we use, dot means out of the page, right? The dark. Notice there's around here in big. Only that tells is the electrons go. The magnet has magnetic field. This, well, it turns out to be pretty cool. Everybody take your left hand. Be aware. Be aware. That's what we were reading the other day. Right? Usually do it. Right. The front of the room. If you have that drawn on page, it page. Page that's from now. Tony's right. You're right. You get your. Some people are like, you had almost claim. It doesn't matter. As long as your nail will. Yours. Let's try this. Into the page. Fingers. Pointing to the right. Right? Or whether you turn your hand or leave it steady, it doesn't be pointing counterclockwise. Kind of pause. Of the particle. Some people get mixed. Part part of my activity. You should have brought in different and paint. Not to draw this diagram. If it helps you, go ahead. You're going to stick your thumb your going to get. Let's make hypothesis. Would you use your left hand or right hand or some kind of combination, or do we have to invent a new rule for that? Or is there something else that we're missing? Would it just balance? What do you mean? No. Cancel. One going to the left, one going to the right, and then canceling. Particle. It's baseball through the air, right? That doesn't generate a magnetic field. Particles. I'm going to be counterclockwise. Some people. Clockwise. Okay. So that. Tony, I saw you hand roll there. What are you saying? Clockwise or counterclockwise? Counter? How come? Yeah. Counterclockwise. How can we have counterclockwise? How can we have the same direction? Okay. The circle's like this. Front. I'm going to stick my left. Which way? This new. Where are my fingers right now? Don't tell me which way they're pointing. The magnetic field here aren't unique to so fingers above the wire are pointing out of the pin. My page for you. This is the page. The page. Good. Into the page report. So we're going to make that X. Now, this is where it gets ready. Another hand earlier. Putting your thumb and fingers behind here, and you're twisting your body. Okay, trying to get your just to Turn your body around a little bit and do it that way. Where are my fingers right now? Right now, Tate. Kind of. Words say in front of the wire, it's toward the bottom of the page. That's okay. Well, don't write it, as long as you understand your own. Here's what I like. Your worksheet booklet that you got on the very first day of class. Open it to, I think it's page 41, worksheet number 10. I have 5 or 6 it's the wire grasp rule, either for left hand or right hand. Find the direction. I'll give you a couple minutes. First one says, draw the magnetic field surrounding. Into the page. For me, it's toward the front of the room. For you guys, it's toward the floor, right? Into the page, however your page is oriented. Okay, fingers go counterclockwise. There's more magnetic field lines than just this one, but we will have the same. Trunk current again. This out of the go clockwise. Electron current again. Good. Left hand. See how most of these problems are negative. This time we want to find it above, below, in front, and behind. Electron current is going right now. Okay, thumb's going toward the right side of the room. My fingers are above the wire. Which way are they pointing? Remember, I'm the page. Which way are they pointing? Into the page. Below the wire, it's in front of the wire, it's toward the top of the page. Don't say up, right? Because for me it's up. For you guys it's not, because your page is horizontal. It's toward the top of the page. You could say up the page, but make sure you mention that page in there. Toward the top of the page, up the page, or behind the wire, it's down the page, or toward the bottom of the page. 4, hey, we got an alpha particle here. That's a right-hand problem. First time we've had a right-hand wire grasp rule. Here's our wire. Sorry to the wire, it goes out of the page, and to the right of the wire it goes into the page. Okay, make sure, a big thing with this one is make sure you use your right hand for that. Electron. Stand. Indicate the direct electron. Ooh, this one. All for D. Here it is. is you got your fingers solving through the thumb. And of course, if you go to the page, then this one, everybody Monday after.